video, we wrote graphs using an equation. So today, let's build on this a little further by looking at a few examples. We're given this equation. Y is equal to 2x plus 4. So how can we graph a line using this equation? Well, let's compare it to our original formula. This is our original formula. Y is equal to mx plus b. Well, what do m and b mean? Remember that m refers to the slope or the steepness of a line, and b is the y-intercept, or where the line meets the y-axis. So, in this equation, the slope of our line is 2, and the y-intercept of our line is 4. Now that we know this, we can graph our line. Let's start by making a point on our line. And let's plot the y-intercept. Since the y-intercept is where the line meets the y-axis, which in this case is at positive 4, we can plot this point on the coordinate plane. So let's plot a point at positive 4 on the y-axis. Great! So we have one point of our line. But in order to draw a line, we need 2 or more points. So how can we find another point? Well, we can use the slope of our line. Remember that we can calculate slope by the rise upon the run. In this case, the slope of our line is 2. So let's rewrite the slope as 2 over 1, which remember is the same as 2. This tells us that from the y-intercept, we must rise 2 units and run 1 unit. So let's do that. From our y-intercept, let's rise 2 units. 1, 2. And let's run 1 unit. 1. This gives us a point here. Now that we have 2 points, let's connect them and graph our line. So, this is the graph from the equation y is equal to 2x plus 4. Let's look at another example. Let's graph a line using this equation. Y is equal to negative 1 upon 5, or negative 1/5, times x plus 0. Keep in mind that negative 1/5 is the slope of our line, and 0 is the y-intercept of the line. So let's start by plotting the y-intercept, which is at 0 on the y-axis. Here is the y-intercept, which, as you can see, is at the origin. Now, in order to find another point, let's look at this slope. We can calculate slope by the rise over the run. So let's look at the slope of this equation. We are given the slope of negative 1/5. So we must rise negative 1 units and run 5 units. So let's start at the y-intercept and rise negative 1 units, which means that we are simply moving 1 unit down in the negative direction. From there, let's run 5 units in the positive direction. 1, 2, 3, 4, 5. This gives us a second point here. And now that we have 2 points, let's connect them and graph this line. This gives us a line, which is graphed from the equation. Y is equal to negative 1/5 times x plus 0. Let's look at a final example. Finally, let's graph a line using this equation. Y is equal to 5/3 times x plus 1. For this equation, 5/3 is the slope of our line, and the y-intercept is positive 1. So let's start by plotting the y-intercept onto this coordinate plane. The y-intercept is at positive 1, so we can plot the point here. Now, let's look at the slope. We're given the slope as 5/3. So, we must rise 5 units and run 3 units, starting from the y-intercept. So let's rise 5 units in the positive direction. 1, 2, 3, 4, 5. Right here. And let's run 3 units, also in the positive direction. 1, 2, 3. So let's plot a point here. Now that we have 2 points, we can connect them and graph this line. This is the line and the graph for y is equal to 5/3 x plus 1.